All right, let's just jump right in. We all learned PEMDAS back in school, right? Please excuse my dear Aunt Sally. It's kind of like the fundamental rulebook for how to solve math problems. But what happens when the problems stop looking like basic homework and start looking, well, a lot more complex?
You're probably feeling pretty good about the order of operations: parentheses, exponents, multiplication, division, addition, subtraction. You've got it down pat, or at least you think you do.
And then, boom, you get hit with something like this. All of a sudden, you've got brackets, you've got absolute value bars, and you've got parentheses all tangled up inside each other. Now, this is where the real challenge begins, and where just knowing the basics of PEMDAS isn't going to cut it anymore.
So yeah, it's definitely time to take our skills to the next level. Let's break down exactly how you can tackle these gnarly expressions with total confidence.
So, first things first, we've got to expand our toolkit. See, the P in PEMDAS, it doesn't just stand for parentheses. It really stands for all grouping symbols.
And that really broadens things up a bit, you know? Of course, we've got our good old parentheses, but then you've also got brackets, which usually pop up to group expressions that already have parentheses. And then there are fraction bars and absolute value bars. You've got to think of all of them as just containers, telling you, hey, solve what's inside me first.
And when you've got these containers stacked inside each other, there's one super simple but really powerful rule to remember: the inside-out rule. I want you to picture one of those Russian nesting dolls. You always start with the tiniest one in the very middle, right? And then you work your way out. It is the exact same idea here.
The other big idea you gotta get is the fraction bar rule. That fraction bar, it's basically a set of invisible parentheses. It automatically groups the entire top part, the numerator, together, and the entire bottom part, the denominator, together. You have to solve those two things as their own little mini problems before you're allowed to do the final division.
Okay, so theory is great and all, but practice is really where it all starts to make sense. So let's walk through a few of these problems together and put our new rules to the test.
So here's a classic nested example. We see brackets on the outside, parentheses on the inside. What do? We follow that inside-out rule. Step 1, find the innermost group. That's 4 plus 1, which is 5. Easy. Step 2, now we solve what's inside the brackets, which has now become 3 times 5, or 15. And finally, the last multiplication, 2 times 15 gets us 30. See? Inside out, simple as that.
And here's that fraction bar rule in action. We are not just going to go left to right here. Nope. We have to treat the top and the bottom like two separate little worlds. So first, let's solve the numerator. 5 squared is 25, and 25 minus 1 is 24. Cool. Now for the denominator, 3 plus 5 is 8. Okay, now that they're both simplified, we can do the division. 24 divided by 8 gives us 3.
Okay, time for the boss level. Let's put it all together. We've got two main chunks here: the absolute value part and the brackets part. We can actually simplify them in the same step. The absolute value of 3 minus 7 is just 4. At the same time, we peek inside the brackets and find another group, 1 plus 2, which is 3. Look at that, the problem's already simpler. Inside the brackets, we're left with 6 divided by 3, which is 2. So what do we have now? 4 plus 2 times 2. And remember your PEMDAS, we multiply before we add. So that's 4 plus 4 for a final answer of 8.
You know, getting good at this also means knowing where the common traps are. So many people make these tiny mistakes that just mess up the whole calculation. Let's look at the two biggest ones so you can avoid them.
The absolute biggest mistake is forgetting that the fraction bar is a grouping symbol. Look at the left side. That's the wrong way. Someone just divided 2 by 4 first. But we know better, right? That bar groups the 6 and the 2. You have to add them first to get 8, and then you divide by 4 to get the correct answer, which is 2. I mean, look at that. A totally different result from one little mistake.
So, to recap, the two things you absolutely have to burn into your brain are these. First, always treat that fraction bar like it's putting parentheses around the top and the bottom. And second, when you see a bunch of nested groups, fight that urge to start on the outside. You have to find the very deepest, innermost group and start your work right there.
So you might be sitting there thinking, okay, that's clever math, but am I ever really going to use this? Well, let me tell you, the stakes are incredibly high in the real world. This is not just for algebra class. I mean, every single line of code that makes your world work, from the operating system on your phone to the apps you use every day, it all relies on these exact rules. Every single programming language, whether it's Python, JavaScript, you name it, it's all built on this fundamental logic. Software engineers live and breathe this stuff every single day.
And when you get it wrong, it has consequences. It could be something small, like crashing an app, or it could be something much, much worse, producing dangerously incorrect results. Just imagine a complex formula for a financial model or an engineering simulation, or, as this quote points out, miscalculating the trajectory of a rocket. The order of operations isn't just some academic exercise. It's literally what makes our modern world work the way it's supposed to.
So that kind of leaves us with one final thought. Now that you see just how crucial this perfect order is for software and engineering, where else is it hiding? What other complex systems, maybe in nature or another technology, depend completely on a precise, unchangeable sequence to function correctly? It's one of those patterns that, once you start looking for it, you see absolutely everywhere.